So let's try to do this double U sub right here, which is really cool. It's pretty difficult as well. The first step we're going to want to try to do is to see the transformation as we move from the X and Y plane into the U and V plane. If we could do that, we'll be able to get some new limits for the U and V when we do our integrals. So if we look at this vertices system, we've got 0, 8, and 0, 9 being somewhere over there, and then 8 and 9 being something like that. So we would get this type of shape forming as far as the X and Y plane. And if we were to try to switch this over here, let's just use these equations. So we'll plug in 8 and 0 into this equation, and we'll get negative 8 for the U. And then for the V, we would get positive 8. So that's that one. And then for this one, we would essentially get negative 9 and 9. And then over here, we would get positive 8 and positive 8. And then over here, we get positive 9, positive 9. So let's go and try to figure out what those are. Negative 8, 8, negative 9, 9. And then over here, we have 8, 8. And 9, 9. So we have this new shape that we've got in the UV axis, something like this. So this will help us to be able to figure out what the U limits will be and the V limits will be when we make our substitutions. Now the next thing we want to do is, I don't know, we'll try to set this up. So we got double integral right here is cosine. And then we're making the U substitutions like this. U is on top and V is on the bottom. So we're making a double U sub. Now, when we have this dx dy, we're going to need to replace that with a du dv somehow. In order to do that, let's go ahead and take the derivative of these two equations. We'll say du equals dy minus dx. Then we'll have dv equals dy plus dx. Then from here, we'll transform this into some sort of a matrix. Du dv equals, the coefficients will be 1, negative 1, 1, and 1. And then we have a dy and a dx right here. Solving this little thing gives us a 1 plus 1, meaning 2. So essentially, we have this little expression that du dv equals 2 dx dy. And we'll divide this side by 2, so that way we can replace the dx and dy with du dv divided by 2. So that was pretty nice. Now we should be able to plug in our u and v limits. So let's go ahead and check this out. If we go from outside being v's, that would be from here to there, and I do believe that should be an 8 and a 9 according to our new system over here. You can see the v's only go from 8 to 9. So we'll put that right here, 8 and 9. Now, on this side, we have two lines over here. It's technically going from all the way from like here to there, if we make a bar across. So this line is actually v equals negative u. V equals negative u right there. And over here, it's kind of like saying v equals u. It's almost like y equals x or y equals negative x. These lines are a slope of 1 or a slope of negative 1 right here. And we're going all the way across from here to there. So the u limits are going to be from negative v all the way to positive v on that one. That was a very important step right there. Key step. Now we'll go ahead and swap this from being negative to positive. We'll just make this a 0, multiply this by 2. We could do this because we know that this graph is going to be symmetrical. So we can do that. And then we'll see the 2's cancel. We'll just make it a little bit easier. Now we'll go ahead and take the integral of the cosine. Should be the sine u over v. And then we're going to divide this by the derivative of what's on the inside, which is technically 1 over v. So we're multiplying everything by v. All right, making sense here, right? And then we'll go ahead and push that from 0 to v. So when we evaluate this, we should be getting, like v sine of v over v, and then it would be minus 0. So yeah, it's just going to be next is 8 to 9, v sine of 1, and this is now over dv. So you just integrate the v squared over 2 from 8 to 9, and there's going to be like a sine 1 over there. So you should be able to get 81 minus 64 is going to be 17, and then that's going to be divided by 2, and there's a sine 1. Awesome. So that is going to be the answer to this one. It's pretty intense.